example of an inverse variation. We're going to put the formula, which is y is equals to k over x. If we substitute the given numbers, it will going to be like this. 4 is equals to k over 6. Cancel this 2, 6. And 4 times 6 is equals to 24. So 24 is equals to k. Our k is 24. We will proceed to the next one. But we will also repeat the formula, which is y is equals to k over x. The value of k is 24 and the value of x is 16. The lowest term of 24 over 16 is 3 over 2. So, y is equals to 3 over 2. Let's proceed to the next one.
So here's another example. If y is inversely proportional to x cubed and y is equal to 1, when x is equal to 2, find y if x is equal to 3. So let's first write the general formula, which is y is equal to k. But then it says here it is inversely proportional to x cubed. So what we're going to do is that the formula will be x cubed, like that. So let's substitute the values that were in the given. So y is equal to 1 half equals to k. And then x will be 2 cubed. So what is the cube of 2, which is 8? And then what we're going to do is times this both with 8, and that this 8 and this 8 will be cancelled out, and 1 half times 8 is equal to 4, and that is your k. Now that we have k, let's find y. So we're going to use this formula again, which is y equals x. And then let's substitute the values again, which is x is equal to 3, y is equal to, what is our k? It is 4, so we'll put it here, and 3 cube. So what is the cube of 3, which is 27? And there is no, you can't simplify this, so this is already the final answer.
Here's another example.
So our next example is y varies inversely with x. If y equals 40 when x equals 16, find x when y is negative 5. So the first step is write the formula of the inverse variation, which is y equals k over x. Since on the problem we're finding x, so we have to move the x on the y. So it will be xy equals k. Then we have to divide both sides by y. So we have to put the denominator so we can divide. Next is we have to cancel y and y. And that's bring us to x equals k over y. So the next step is finding the k. So to find the k, you have to multiply 40 and 16 since they're both y and x. So we're going to multiply them and we're going to get 640. And that is our k. So the next step is doing the formula now. So I have to divide 640 by negative 5. And if we go to divide that, we'll get negative 128. And that is our x.
And this is an example of an inverse variation graph.
In inverse variation, we may encounter graphs. So in this topic, how will we use graphs? And how will we understand them? And how is it relevant to the topic? To give a simpler explanation of the topic, let's use this example. The area of a rectangular garden is 12 square meters. The following are some of the possible dimensions of the garden. Suppose that this is the rectangular garden, and as said in the statement, the garden has 12 square meters. So for one row, there must be 12 units in order to complete 12 square meters. To create another possible dimension, we must think of another way or arrangement of how to complete 12 square meters in different ways. We already used one row with 12 units, so we must think of another one. Here we have another possible outcome. 2 rows with 6 units each. Having this, we can still complete 12 square meters. 6 and 6, 12. So what's important is that we must get 12 square meters. It doesn't matter how many rows or how many columns. All that we need is to form a garden with 12 square meters. So it can be three rows and 4 columns. So for 3 rows, there will be 4 units each. 4, 8, 12. Still 12 square meters. Or it can be 4 rows with 3 units each. Still 12. It doesn't matter what combination or arrangement we use, and we can think of any number as long as the output will always be what is being asked. In inverse variation, we may encounter graphs. So in this topic, how will we use graphs, and how will we understand them, and how is it relevant to the topic? So here's the table with all the possible dimensions that we got from the 12 square meters rectangular garden. So we have X for the width, which are the rows that made up the garden, and Y for the length, or unit per row, are the columns. So as said earlier, we got to create the garden with 1 row and 12 units. So for the second one, X, which is width, is 2, and Y, which is length, we have 6. For the next one, we have 3 and 4, and for the other one, we have 4 and 3. So how would we plot this into a graph? So here we have the graph with our length as the y-axis and the width for the x-axis. So now all we have to do is plot the points using the table that we've created from the possible dimensions of the 12 square meter garden. So we have 1 and 12, so we simply look for 12 and 1, y-axis 12 and x-axis 1. So we put the first point here. The next one is 2 and 6, so we put the second point here. For the third one, we have 3 and 4, so we put the point here. And for the last one, we have 4 and 3, so the point goes here.
Thank you for watching!
What was your favorite part of the video? I hope you have learned something from this video.
Watch here for more tutorials. Like and subscribe for more.
Bye!